here I would say the method 1. So here is the principal stresses in 3D. The method 1 is what we did last time. We solved for the eigenvalue problems. So that means tau 1 1 minus sigma, tau 2 2 minus sigma, tau 3 3 minus sigma, tau 1 2 1 3. The 0 bar, that means that's the 0 column vectors. So solve for this one, for sigma and L1, L2, L3. And for example, you can use MATLAB using the EIG and say tau. Okay, tau is the given stress the vectors. The second approach is to use more circles. And how to use more circles to solve for this one. And here I would say more circles. Okay, and for 3D we would have 3 circles. And these are limitations. Limitation is this: the more circle, to make more circles working and solving the 3D stress element is this. You need to identify at least one principal directions first. Okay. So the more circle, using more circle to solve for 3D, you have to start with a spatial orientation, and that orientation contains at least one principal stresses. If not, then more circle won't apply. Okay, so for example, so this is x1, x2, x3. So let me make up one, and this will be similar to your homework. And say, for example, here we have this stress, for example, 10, and symmetric balance on the other side. And here we have, for example, 4, and here is 10, and here is 3, 4. Okay, the strain stress is 4, like this one. So this one, I believe, is similar to your homework. So for this one, first one, let me show you the 2 approaches. So this one we determine the principal stresses and the principal directions. The method 1, and we can utilize, we solve for that question. So basically the first one, we write it down, what is our stress matrix. And in terms of the coordinate systems, the normal stress in x direction, this is 10. The normal stress in the second direction, that is 4. The normal stress in the third direction, that is 10. Okay, now the diagonal elements, those are the strain stresses. And here for symbols, this is tau 1, 2. In one plane, pointing to 2 directions, so this is 0. And this is tau 1, 3 in one plane, pointing to the third direction, so this is 0. Okay. This one is tau 2, 3 in 2 plane, pointing to the third direction, so this is 4. Okay, and this symmetric, so this is 0, 0, 4. Okay, you have to write it down this one per the coordinate systems we are given. So here you simply using MATLAB, EIG, and tau, and this one will give, so for example, LV. Then once you hit return, then L will be given 3 ABC, sigma 1, sigma 2, sigma 3, 0, 0, 0, 0, 0. Okay, so that is the first one, and V will be equal to certain numbers, I don't know, okay? So this is the principal, the first principal stress. This is corresponding N, that is the principal direction corresponding to this one, okay, etc. So this is the first approach. The second approach is using Mohr circles, okay, and how could we do this one? For this question, you can see the x1 direction. You can see in the x1 plane, they only have normal stress, no strain stress. So this one already, this is one of the principal directions. Okay. So if that is the principal directions, and again we work on, as long as we identify one, then simply you can see we try to simulate, not to simulate, we try to reformulate the 3D problems into combination of the 2D. The way is this, we simply put the little guys and sitting onto the principal axis, looking into the stress element. And here is the way to get the projected information in 2D. Okay, so the step is this. From there, we're looking into that information. Then probably from here in front of the little person, this is x2 axis, x3 axis. Okay, and then what he see in his viewpoint projecting into his eyes is this is 4 and this is 10.
Really quick.
Yes.
So just to let you know, L and B are backwards.
Yeah, either way. Yeah, because I forgot the orders.
Yeah.
Yeah,
No.
so-
I mean, I'm trying to say that.
This should be V, this should be L.
Yeah.
Yeah. So yeah.
Or that's
okay.
what. If
You
you
know
do
what?
that order, that's what.
Okay.
I don't
That's
know.
important. Okay. So thank you. So now for this one, you can see this is a typical Mohr circles, but that is representing is the projected. So we draw this one quickly here. So for this one, we can see the center. The center is at 10 plus 4 divided by 2 is 7. And the radius is equal to here 10 minus 4, 2 square plus 4 square equal to 5. So for this case, the Mohr circle is okay, this is this one, and the center is 7, and this radius is 5. So that should be like this. Okay, the Mohr circle like this one. And this one representing is the x2, x3 planes. So now for this given point, we can label the points here. So in the x2 planes, the coordinate is 4 and 4. This one, the second one is the strain stress that has the directions. So this is like this. Okay. So for the x2 plane, why not I just label it as x2? So in this way, the 4, 4, that should be around here. Right? Okay, so that is so this is our x3. Okay, and x3 represent is the status of the stress in the x3 planes. So for this case, the principal orientation of this is where? So here we can label it quickly. Is here. and here. So for example, if we choose this rotation here, okay, so this is our 2 theta p. Right, so here we can calculate 2 theta p. 2 theta p will be equal to, we can utilize this triangle here. So this triangle, this is 3 and this is 4, right? And so this is 2 theta p. So here the 2 theta p should be equal to 53 degrees. And remember, this is 37, this is 53. That's a special triangle in order to memorize. Okay. So here this angle is 53 degrees, or arctangent of 4 over 3. So here the 2 theta p equal to 26.5 degrees, and direction is clockwise. What this means? This means here we get onto a clockwise 26. So from here, 26.5 degrees in that new orientation, we have the element. Okay, so in this direction, x2 rotate into here. So this is our x2 prime, and this is our x3 prime. So x2 basically follow up this rotation, move to here. So in that direction, we have the magnitude. That is how much? This is 2, and this is 12, right? The magnitude. Okay, so in this direction, we have the normal stress is 2. Here is 12. That is the old stories. And this one, I want to impose this drawing into the 3D. How to do this one? You think about this one. This one is obtained by rotating clockwise about which axis? About this axis. So that means we're rotating about the x1 axis clockwise.
You have to do this 3 times.
For this one, only 1 time. In general, 3 times. But anyhow, we look at here. You can see this rotation is about which axis? About this axis, right? About this axis. So basically, if we have, let me utilize this one representing this element. This face is the x1 face like this. So right now, we simply rotate this one by 26.5 degrees. This represents here, this is the principal directions. Got it? Okay? Will be okay? So in this way, so that is the principal directions. And then in this way, how to write down the n vectors. N vector 1 is this. This one, principal direction n, for this case, is 1, 0, 0. Okay, and for this one,
Wait, why is it 1, 0, 0? Are you just claiming it to be
because
that, or like?
because this
that
one, yeah, this already is a 1 principal direction,
Okay.
and pointing to that one, that has the vector like this.
Oh yeah. Okay.
Okay, and now I'm going to write the second one. What is this directions? That direction simply is given by this direction, right? I'm going to mess up the drawings. So here, look at this carefully. This is the directions, and that direction is how much? Let me draw that here. So this direction, this is 26.5 degrees. So this direction, in terms of the 2D, it has 2 components. This one and this one, right? This one is how much? Is a cosine, 26.5 degrees, and this one is minus sine, 26.5 degrees. So this is the x2 coordinates, this is x3 coordinates, right? So here for n, we have 3 coordinates, x1, x2, x3 coordinates. So for this case, n, you can see this vector is if the x2 and the x3 plane, this vector didn't have inclination out of the board. So this vector has 0 components in x1 direction. Would that be right? The x2 coordinate simply is this one, cosine 26.5 degrees. The third one minus sine 26.5 degrees. This should be the n, the vector, the principal direction representation of the principal directions for this direction, for the second one. And you can do the similar things. This one, basically this vector is pointing to here, then you can project it into the similar way. Like, okay? So for your homework, I didn't ask you to give me the principal directions, but on the magnitude of the principal stresses, right? So here again, this circle, let me, based upon this one here, and redraw the 3D. This is our principal directions, so that means